Hello everyone, this is Surabhi Gupta and in this video I'll be talking about our work titled Facial De-occlusion Network for Virtual Telepresence Systems. Human collaboration is a vital component of any successful large corporation. Globalization has led to an acute need for remote interactions for effective communication that has been further boosted due to the current pandemic situation across the world. Currently, video conferencing is the most prominent solution for remote communication and there are many available options, but there is a lack of immersiveness. So how can we get a better immersive experience? We can combine the power of virtual reality and deep learning to design an AR/VR telepresence system that can mimic real-life human interaction to some extent. Motivated by the challenges that still exist in current VR-based video teleconferencing applications, such as a large portion of the face is occluded by the head-mounted display due to which facial expression and gaze cannot be effectively captured, hence hindering the user experience. Exchanging VR media requires a large amount of information to be transmitted, which may not always be possible in a low bandwidth network. Person-specific virtual avatars are expensive to adopt, for frame animation is computationally intensive and requires high bandwidth to transmit the server. Thus, we need a simple yet cost-effective solution to enable virtual interactions that enhances user experience even in low bandwidth scenarios. We understand that the face plays a key role in human interaction, as it offers subtle visual and non-verbal cues which helps to understand what others are conveying. Hence, to mimic physical face-to-face interaction in a remote environment, we focus on HMD de-occlusion for VR telepresence systems. Thus, to solve this challenge from a computer vision perspective, we pose this problem as an image inpainting task. Prior works on face image inpainting do not produce usable results. They suffer from loss of identity and fail in cases of non-frontal poses. Avatar-based methods relies on large amount of multi-view calibrated data and expensive computational hardware. We propose a novel attention-enabled encoder-decoder architecture that can use background and appearance details from the input image and allows the model to focus on inpainting the occluded region with plausible details. We train the model in 2 stages in a person-specific settings. Next, we show the results generated by our facial de-occlusion network on different identities. Our method is also able to generate realistic and semantically consistent reconstruction across the frames. We also compare our method with various image inpainting methods that have been validated on faces. These are some per frame video results generated by our method. We also evaluate our method quantitatively using image reconstruction metrics such as SSIM, PSNR, and LPIPS. We also show the enhancement in facial animation models such as form and the applicability of our method in hybrid telepresence systems. In low bandwidth environments, by just using sparse landmarks, our face image can be animated reasonably well from a reference image. We also generate 3D model of this animated face using existing methods such as DF2Net. In the scope of this work, our model does not guarantee temporal consistency and might not produce smooth facial movements such as opening and closing of eyes. With a view to capture subtle facial movements and a variety of complex poses and expressions, as the future work, we are currently working on extending this work to improve reconstruction around the eyes, adding temporal consistency to per-frame reconstructions. We will also be working on dealing with extreme lighting conditions and integrating our work with AR/VR based metaverse applications to solve real-world problems.